What's up, man?
Hey, how's it going?
Good, good, good. So yeah, as I told you, let's talk a little bit about
Mhm.
bias, like real bias in science. So I think it was a year or two, 2 years ago. I've heard from Jonathan something about Fisher.
Yeah.
So yeah, let's talk about the racist part first, and then I'll explain what does it mean. What did he do for estimation society? So yeah, because
Yeah.
he's a big
We'll start by pulling up the wiki on him.
guy. Yeah,
Uh, let's see. What was his name? Ronald Fisher? Something.
Fisher. Yeah,
Yeah,
yeah.
Ronald Fisher. Yeah. So, there's some stuff on eugenics here that is kind of what he's most infamous for. And so he was like, I think his early scientific work was involved a lot in like ecology stuff. So
Oh,
studying
okay, okay.
studying how populations of animals they develop their genetics, that
Yeah.
kind of thing, what makes them most well suited for predation, right? And that sort of thing, and that really informed his views of eugenics, which is not something that we think of it more as like a pseudoscience nowadays.
I
But at the
see.
time, I guess this was more well accepted, and so he would talk about Darwinism and what attributes in humans can be ascribed to genetics, and what attributes different races had that made them like more intelligent or more adept for certain types of physical activities than others. And so yeah, it was like it's like a whole thing. And it says here, it talks about forced sterilization of certain races, so
Oh, I see.
really, you know probably not okay stuff, especially by today's standards. So um
When was the okay 19?
yeah, 1912, right? So
Okay,
this is
1912, and in Britain, right?
yeah, I'm not sure. Yeah, I mean it should have been in Britain, yeah, Cambridge Society. So
Oh, okay, okay, yeah.
this is leading up into World War One era. Um
Mm-hmm.
and so yeah, it's a really long
Yeah.
time ago now. But it's important with all of these, when you talk about Fisher information, right, or Pearson correlation, and we need to understand the context in which these measures came about, and the societal and cultural context in which these scientists did their work and made these theories and ideas.
Mm-hmm. But
Um,
wait, so is this the same Fisher that did for the estimation?
yeah, yeah, yeah. Fisher information, yeah, that's him, and
Wow. And he
various
did.
other.
Oh yeah, yeah, yeah. I'm looking at the. Let me see this one. Can I share?
Yeah, go for it.
Yeah. So this one, Fisher information. Yeah. So do you know what this theorem says?
Yeah, it's something. It says something about like the log likelihood, right? Something about the
Yeah.
variance.
So let's say you want to solve a problem. You want to solve an estimation problem, and you're
Yeah.
trying to estimate something.
Hmm.
Definitely have some error, right?
Yeah.
So let's say I'm gonna show the error by this variance of theta hat.
Yeah.
So Fisher says it's basically there's a lower bound on this.
Yeah.
So
Hmm.
you can't do anything better than this.
Hmm.
And this is actually proportionate to this 1 over Fisher information matrix, the determinant, I think, for the
That's right.
general case. So yeah, so it's a really fundamental theory. It's a I don't want to say the most fundamental, but like it's a really important.
It is one of the most
Yeah,
fundamental.
yeah,
For
yeah.
It's like
Yeah,
first thing you learn in estimation theory.
exactly. Yeah, and it's basically the base for a lot of things that we do in machine learning and
Yeah.
engineering and
Mhm.
computer science. Yeah, and it's really interesting that he was also doing. What was the term for? What was the other area he was working on?
You mean eugenics or?
Yeah, 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 yeah,
Yeah,
yeah,
yeah,
yeah,
yeah.
yeah, yeah. So,
So, I mean, a lot of these guys, they cut their teeth doing genetics research, right? I mean, you look
mhm,
at Mendel and all of the OGs, right, doing this stuff. they're interested in like plants, how to get better plants, how to breed better animals, right? And so this is
Mhm.
where these original statistics came about. Even like students t-test, right, was for brewing
Oh
beer,
yeah, yeah, I
right?
remember that. Yeah, yeah, yeah.
And
That's
he
also
was
interesting.
employed by a brewing company, I think, and he couldn't publish his work under his actual name, so he published it under student, right? That's
Mm-hmm.
not his real name; it's a pseudonym, right? So,
Yeah.
um, yeah, I mean, so that was very much the cultural and economic context that this stuff
Mm-hmm.
was coming about within, and so yeah, at that time it was probably more well accepted. And I think it's important that we don't look back at things that were done and views that were held in those time periods with like modern sensibilities, because probably in 100 years people will look back, maybe hopefully, at what we do and say, that either that was good or they were wrong to refer to their subjects as subjects, right? Or participants. Maybe that's like we were racist for doing something like that. So I don't know. All right. Yeah, we
Yeah, that's an
have the
interesting
context
point
that
of view. So you're saying it's like, as a scientist and in the context of what he was doing, maybe he didn't, something like that, he didn't mean
I mean,
to.
yeah, he didn't for him, and a lot of people back then, they have these underlying biases that propagate up into their research work, right?
Especially that era, the over there, that era,
Yeah,
everyone was like, yeah,
yeah, and there's a really good book about this. It's called The Mismeasure of Man by Stephen J. Gould. So uh Mismeasure of Man. Yeah. So this is a really good book, and it talks about a lot of these they used to claim stuff like African people are more, that they have a larger skull or something, and that this
oh
is
yeah,
correlated to less intelligence. And then they measure this by putting steel bearings in the skulls of different races, and then they say something about, you know, they say something about intelligence that's correlated to this. But there's all sorts of
I see.
fundamental experimental like flaws in the design, and they sort of, because they want to believe that these are true and this is the way it is, their experiments are flawed, but they still come to the conclusions that they want to come to. So
Mm-hmm.
they don't have the rigor of the scientific method that we have now. And so it's important when you look back that you understand, yes, this is interesting research that they did in some aspects, but it's also maybe flawed in other aspects from a bias perspective, like the experimenter bias, or it's flawed because of actual flaws in the protocol,
Mm-hmm. Mm-hmm.
or both. Right. So
Yeah.
um, yeah, we have to be cognizant of that now.
You
And
know, I was thinking about the fact that Fisher, so the main theorem that Fisher talks about is bias, right? So
yeah.
he gives a lower bound on bias, and he's
Yeah.
also biased. So it's kind of, I don't know, I was thinking about this. It's really funny. It's the whole life you work on it, and
Yeah.
then at the end of the day, you're also, I don't know.
Yeah,
But
there's an irony there for sure.
yeah, yeah. So speaking of bias, I was talking to a friend of mine about bias in data sets,
Yeah.
because for especially for language processing, a lot of data sets, they've been gathered from internet all over the place.
Yeah.
Like
Yeah. Mhm. Twitter or something.
I yeah, so it says Hungarian, I think. Yeah. She is beautiful. He is clever. He reads. She
Ah,
watches. Yeah. So,
but if you look on the left, it's not
yeah.
gender.
So in gender neutral in that language, Hungarian. So yeah, I think for Farsi is like that. And
Uh-huh.
when was this? This is pretty old. And I think they fixed it. But what this shows is really interesting. So the data sets that they're using for all of these models, large language models, are um we made them, right?
Yeah. Yeah.
We
Yeah.
we all have
It's a product of
biases. Yeah, yeah,
cultural
yeah, yeah.
biases. Yeah.
So
Yeah.
that was a really um I would say it was an important point that they realized, oh, okay, now that I'm seeing it, because that's what I'm doing, machine learning, so the data is reflecting what's happening.
Yeah.
And for the DNA data sets, I was talking to a friend of mine. He's studying at San Diego, UC San Diego. So for the DNA data sets, he was saying that most of the data sets that they're working on,
Yeah.
they're white, mostly men.
Yeah. Yeah. Yeah.
So like two dimensions, for bias, the race, black, white, and
Yeah.
also the, gender.
Yeah. Male, female.
Most of the results or the databases, the, experiments, the cool machine learning things that they do, a
Mhm.
lot of them are based off of the data sets that are mostly biased towards male, white.
Yeah.
Yeah. And then now I understand that why most of the, when you want to write a grant, they talk about, inclusion, gender in terms of race, ethnicity.
Yeah.
It makes sense to me now why they want to like they want to make sure that it's all like distributed uniformly,
Well, I agree and I maybe disagree a little bit, right?
Mm-hmm.
In terms of like, if you're applying for a grant to carry out your research, I think it's important that if you're going to collect data or analyze data or something, that that's done in a way that's not biased. But
Yeah, yeah, that's a good
is it
point.
important for, when you apply for some of these grants, right? NSF stuff in particular, they'll ask you about broader impacts and this sort of
Yeah.
um for a lot of this, it's like you're more likely to get the grant if you're a person from like a disadvantaged community or background. And that to me, at this stage in your career where you're a researcher and you're running a lab or you're a PhD student, I don't know that that really has a place. And there's been a whole thing
Mm-hmm.
now with the affirmative action
Yeah. That's
being,
important, and I agree.
yeah,
But what the only thing I can say is that what's the solution?
I don't know. I don't have a solution, right? It's easy to complain. It's hard to come up with
Yeah, because I
something
was
done.
also thinking about it. It might not be fair to others,
Yeah,
Um,
well, I mean, this is a whole,
but
I mean, it is biased, but I guess we're talking about bias in a way that it's going to impact our data and maybe not bias in a career oriented sense. So
yeah,
maybe
yeah, 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 data. Yeah.
I'll shut up about that for
No, no,
now.
no, 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 no. But it's complicated. They're all
It's a very
related. Yeah, yeah. It's the
yeah,
dynamic.
yeah.
Um, but yeah.
But
Go ahead.
definitely with the example that you showed, right? I mean, my opinion is that a lot of the success that we see in these large, really deep models is derived from the fact that they're able, because they're so over parameterized, to compensate for the lack of data that's available,
Mm-hmm.
right? So you feed in garbage data to a DNN, and it is capable of
Doing
sifting
something.
from the chaff and finding something valuable in
Yeah.
it, right? Whereas I really think if you had a clean data set and you put it into one of these things, that you'll get a similar result using, nonlinear kernel and a SVM or something, right? Like something similar, simple minded. Um, yeah, I don't
I
know.
know, like basic stuff. Yeah.
Yeah, yeah. I mean, this has been my experience before, and I mean, you know that there are theoretical bounds on how much performance you can get on any
Mm-hmm,
given data
mm-hmm,
set, right?
mm-hmm,
Whether
mm-hmm.
it's easy to find that or not, what that bound is a different question. But there is some bound of like how well you can perform on a data set, and so anything further than that, you're biased, you're overfitting, right?
Mm-hmm.
And I did a study, just as I was exiting my undergrad into grad school,
Mm-hmm.
professor, and we found the upper bound of like the classification accuracy. I can't remember the name of the theorem now, but it says something along the lines of if you can like any neural net will achieve the
Approximate
same
a
level.
function.
Yeah, it'll
Yeah, yeah,
approximate
yeah.
function, but that same thing can be found using a KNN with varying the number of neighbors, right?
I see.
Depending on what distance function you use, et cetera, right? But there's some like way that KNN can also be like a approximator for like
Yeah.
classification.
Yeah.
test, right? So we show that the upper bound is something like 97% accuracy. And then you go
Mm-hmm.
and survey the field, nobody does better than 97%. And you can make a classifier that can overfit slightly and do maybe guess a little bit better for some of the test cases, but there's nothing that can eke out that last
Mm-hmm.
3% is theoretically just not possible.
Mm-hmm. It's really
And so,
interesting. But
yeah, yeah.
I just wanna say that. So from the other side of the spectrum, when you're like an applied person,
Yeah.
right? I know at the end of the day they are uh like DNN is kind of similar to what's happening in SVM, maybe with the different computational complexity, but um for applied people it matters what to use, and this only comes from the experience based on what I'm seeing.
Mhm.
So how would you how would you
Well,
defend your side given this?
so
So
what
let's say so
question a
that
little.
matters to you. It
Mhm.
matters to you that I want to interpret the thing, what's happening.
Yeah, yeah,
So
very much. Yeah.
yeah, but for some people it's just a matter of classification. So I don't care right now if it's SVM, if it's I don't know like a linear affine function or it's like a deep neural network. It
Yeah,
matters to implement
I
something.
understand that perspective, right? And I think, I've heard it called the difference between the engineer and the scientist, which I take offense to this, but as an engineer, but the engineer is only concerned with improving the accuracy, improving the performance. They don't care why. You give it a black box with an oracle inside
They
of
do
it.
care why, but maybe not the same way that you do. Maybe it's like more money wise, for example.
Well, like if you're in the business of building a self-driving car, throw away the ethical concerns, right? And you just
Yeah.
want a car that can navigate the city better than Uber's
Yes.
car or Lyft's car, right?
Yes.
Um, and I give you a black box and I say there's a genie inside of this one that will, do better than what they do. Are you gonna, how many questions do you ask, right? Besides the ethical concerns, right? You're content to have a box that does better than the competition, right? If there's a
Mm-hmm.
classifier that recognizes images better than the other guy, then you're happy that you have that. You don't really
Uh-huh.
care that it's going to do worse on black people, right? You
Mm-hmm.
don't care that it's going to
Mm-hmm.
hit a pedestrian, if they're shorter than everyone else, right? Um, it barring the ethical concerns, right? So the scientist is very much concerned with these things, right? The scientist wants to know what's going on inside the box. They don't want a box that works magically that can never be looked inside of. You'll never know how it works. That's not
Mm-hmm.
something that will help us. So
I'm a fan of having both sides, to be honest, both left and right, because I think that generates a dynamic, and it kind of like, because if we are like too scientific on things, we can't make anything. Everything is gonna be theory. But if we are like too much engineer, as you said, a lot of things that we're gonna ignore
yeah,
about, but they're really important, right?
yeah.
We shouldn't.
Well,
But
yeah.
go ahead.
I definitely agree. I think
It's like left and right, like
I think for me,
too
my how hard line my stance is depends on the use case. If you want to have a guidance system for a rocket, or you want to have a self-driving car that's going to drive around the city with children and stuff, I think whatever you use needs to be transparent and it needs to be rock solid.
that I agree, definitely,
But
yeah.
if you're making, something that's going to generate art, or it's going to, make the character movements in video games smoother and more realistic, then yeah, use the deep network. We don't care what's going on inside as long as it works better than last year's, right? So for me, it's a matter of like whether we're looking at science or we're looking at media and maybe artistic uses for this kind of stuff.
Nice. Yeah. But just one short thing about the self-driving cars. So I was talking to a friend of mine who works for Huawei Canada.
Uh,
So they're doing a lot of cool projects on self-driving cars. And so I was talking and I was asking like what's the basically coolest what's the basically idea that you guys want to do, and it's really hard, and people are like trying to like get there. So he was like, they don't want to use a simple deep neural network, which is basically like a, you know, if else, if else, if else machine.
Yeah. Okay.
They really want to learn it by interacting. So they're
Mhm.
like a Q learning thing,
Okay.
like a,
Yeah.
you know, like an actual learner.
Yeah. Yeah.
And
More reinforcement learning, less just vanilla classification.
yeah, not vanilla. And the important reason is that, so if you, let's say you train a model with a data set, what happens is that this model might be not, what's the word for it, reliable for the out of distribution inputs, right?
Yeah.
But when you have Q learning, so what happens is that you're letting the model being trained by having, you know, interactions with
Yeah.
the
Yeah.
environment. So it's like, you know, when I'm a kid, how do I learn? You know, the actual
Yeah.
interaction.
Yeah.
And that's like a really hot domain. And this is really interesting. And I'm seeing some connections in neuroscience.
Mhm.
So yeah, maybe next time we can talk a little bit about that. But
Definitely.
that was really interesting, from bias to bias, you know, theory to
Yeah. Yeah. I mean,
yeah.
there's so many different kinds of biases, right? And it's an interesting area to study. It's important for everyone who's working in research to have an understanding and at least like a peripheral awareness that there is bias in everything. And we need to do our best to limit the introduction of bias into our own psyches, our own data sets, our own classifiers,
Definitely.
right?
Yeah. Perfect. Yeah. So I'm following a YouTube channel. I forgot the creator's name, but he always says it's a good place to stop. So
Yeah, man.
I would say, yeah, thanks for your time, and yeah,
Yeah, thanks for
talk
having
to you
me.
soon, man. Yeah,
Yeah, we'll talk soon.
thanks.
See ya.